In this video, we're going to be going over a lathe tutorial from inside of BobCAM for RHINO. So when we bring in our geometry for lathe, we want to put the center line of the cylinder. So you got to think of this as a solid model, as a round part. The center face of it right at the XY0 there. And this is representing that I have a hole down the middle of this part right here. And there we have it. So I'm going to go in and turn it, cut some grooves, and call it a day. Drill a hole. It'll be pretty easy. The big thing is we really don't need perspective view, front, or right. So I'm just going to go to the top view so I can focus on just that view there. Now to get started, I'm going to right-click on CAM defaults here and go down to New Job. And then I'm going to choose Turning. Now when I choose Turning, it's going to give me a lathe, and you may have more than one lathe available. I'm going to use this BC2X lathe, but really all the lathes are the same. The most important thing is that you have the right post processor for your lathe. So you can use the BC2X lathe with a Haas post or an Okuma or whatever you got. You can actually use them together and it'll work out just fine. Now from here, I'm going to go right into the stock wizard. So when I say stock wizard, I can pick my geometry if I had a solid model for my workpiece, but I don't have a solid model, so I'm just going to ignore that and go past it. And then right here, I create my stock. Now we have two types of stock that we can select when we're doing a turning job. So we have our cylindrical stock or we have revolved stock, which means I go in and actually pick geometry and tell it to revolve that stock. Now in this case, I'm going to go with a cylindrical piece of stock, and I'm going to define it to the size of a stock diameter that is 6 inches. We have an internal diameter at 0 because I don't have a hole through the stock. The total length of it's going to be 8 inches. And because I used the revolve a second ago, it's thinking that the front face of the part is here. So I'm going to set my stock origin at just 0.1. And this is going to leave me some geometry in front of the material that I'm going to be able to face off with a quick face pass. Now when I hit next, I then have my clearance planes. There's no other origin. The origin defaults to right here. So I have my face at 1 inch. So it's going to stay 1 inch in front of the part when we wrap it around. It's going to stay 1 inch off the diameter. And then if I had an ID, it would be at 50 thou. But in my case, I'll just hit OK. And then I'm going to go ahead and blank out my stock. Now, before I start tool pathing this, I want to go in and load in the tool crib because I have a couple tools in here that are kind of custom made. They're a little bit longer to be able to do some of these grooves. So I'm just going to right click on turning tools and say tool crib. And then down here, I'm going to import my tool crib from right here, the lathe tool crib, LAT cribs is what it's called. So we'll say open. And then there's the 6 tools I plan on running. And the big thing I changed here is on my grooving tool, we have it sticking out a little bit further to be able to go in and make those cuts. So I'll go ahead and hit OK. And then I'm going to right click on Machine Setup 1 and do a lathe end face. So from here, I'll just select my geometry. And really, I don't actually have to pick geometry, but I'm just going to pick the front line right there, just that front face line, and then hit OK. And then go next. Now, if it tries to pick the full chain, remember you can go into the sub-entity picking by holding Control and Shift at the same time. But in this case, I have it not joined together, so it didn't ruin anything. Right here, I have my rapid plane, so it's going to be 200 thousandths in front of the front face of the part. It's a front face type cut for the feature, and I'm doing region 1. If you go region 2, you're going to start from the center and move away. I want to start from the OD and move to the ID. Right here, I could tell it whether to go from a stock amount. So what's the stock? Do we want it to read the stock and cut it, or do we want to just go with a custom amount where I can define that? And then right here, we have some extensions. So how far above the part do I want to start? I'll give it a little 1/8 inch there. And then how far past center do we want to go? I'll give it a 1/16 of an inch right there. So just 0.0625. And that should give us enough to get rid of the little tit that's going to be left at the tip of the part. So right here, I'll say next. Right here's my machining strategy. And the strategy for this is either an end face rough or an end face rough with a finish pass. So the finish pass would just be used to clean up any excess. I'm not going to do a finish pass. I'll just go with the end face rough. Go next again. Right here we have so we have a choice of doing separate moves where we list out every movement of the tool, or we could do CAN cycles depending on what you have in your post processor. You need to make sure that your post processor has the correct CAN cycles before you go try and run them. So I'll leave it on separate moves. Right here we then have our roughing tool. So it's going to choose tool number 1. And if I'm not sure if this is all the right tool, I could go to my tool crib and I can see there's my CNMG, and then I'll just go ahead and hit OK. And there it is. If I say show tool holder, that's what the tool is going to look like. And basically just the tool I got. So it's a CNMG. It's got a 64th rad for the nose, and the inscribed circle diameter is a 1/2 inch. So if you have smaller inserts, you're probably going to change this inscribed circle diameter to their inscribed circle size, maybe a 1/4 inch or 3/8. Right here we have our insert orientation. So this is the orientation that the tool is sitting at. We could say it's orientation 2 or 3 or 4. We could even turn the tool horizontal and then choose 1, 2, 3, or 4. But in my case, I'm going to go with vertical, insert orientation number 1, tool number 1, offset registers number 1, and then spindle direction, I'll go clockwise. I do choose between clockwise or counterclockwise. I have my coolant of flood, mist, air, oil, or off. And then right here for feeds and speeds, we could either set it up with an RPM or a constant surface speed. So I'm going to leave it on constant surface speed and then hit next. Right here's my pattern. So how do I cut this part? Either I do a standard cut, and we just start at the beginning of the cut. And in this case, it's a face, so it's just going to cut its way down, go back, cut again. We could also do a zigzag with that option, so it actually zigs its way in. Not something I've used much on really anything, but especially not facing. And then the other option is offset. So we basically follow the shape of the geometry as we cut the geometry out. I'm going to go with a pretty standard one and just say standard with a standard sort. And then right here we have our compensation. Now, if you're defining your tools properly and you're defining the correct holder, you can go in and say on with collision detection, use the tool holder. And this will ensure that we don't drag the holder across an area on the part that can't be cut with that holder. If you're not using the on with collision detection using the tool holder, you're primarily going to be using a G41 or a G42 so that you can offset your tool manually. For me, it's pretty much always going to be on with collision detection using the tool holder. Next, I then have my parameters. So how much am I taking off in my depth of cut? How much am I leaving for my allowance? So for my depth of cut, I'll say, yeah, 50 thou. But I don't want to leave any allowance. So I'm going to put these both at 0 so that with this one rough pass, I can finish the entire front face. Right here, we have options for overlapping, which really don't come into facing too much. These will pop up more when we get into the turn rough and the turn finish. So I'm just going to leave it on no overlap. Right here, we have our chip break options where we can come in and tell it our length of cut before the chip break. We could say the time, or we could actually tell it the length of the chip, and it's just going to retract the tool and break the chip. So I'm not going to do any chip breaking right now. We have our corner types here, which again, a lot of these options, you get them in both face, but you'll also get them inside the turning. So when we're actually roughing the OD, so these will come in handy more with the OD than they do with a face cut, but you can choose whether you want to do a round interpolation of your corner or a sharp interpolation of your corner. I'm going to go ahead and leave it on round. And then there's also an option for trim to stock. And this is helpful if you've already roughed some of the material out and you don't want to let the tool path go into areas that have already been cut. You can actually create a model that represents what's been cut and what hasn't been cut, and you could use it as a trim to stock option. But in my case, this is the first cut we're doing, so I'll go next. Right here's our rapids. You have a default rapid on your approach, which is primarily what I use, especially with the part like this where it's all pretty much OD work. I'll just say use a default rapid on the approach and a default rapid on the exit. But you do have different situations. You could say I want to start from the OD or ID or face clearances, or you can rapid from a defined point. Now, when you see the values that say X-Z, it means X and then Z is going to move, or Z and then X. But with these ones that don't have a dash, it's an angle there. So it's just going to be an angle straight in. So if you can't do that, don't do that. Like I said, with most approaches, the default rapid on the approach works pretty good. The default rapid on exit's kind of the same thing. You're just going to tell it where to go. So you set up a tool home, a cycle start, or a defined point. And again, same thing with an X-Z means X, then Z. You really have to be careful with that when you're doing ID cuts just to make sure you don't take off in the X direction and run through your part and then come out. So just make sure, most of the time, try and start it with the default rapid on exit, set your home position, and hit compute. If you see a problem, then go and change it. But most of the time, the defaults do a pretty good job. Next, we then have our leads. So we have a parallel lead in, a perpendicular lead in, a horizontal lead in, a vertical lead in, an angled lead in, or a custom where we get to define X and Z. In this case, I'm going to go with a parallel lead in, and then I'll do a perpendicular lead out, and I'm just going to leave them both at 100 thousandths there, and then hit next. Finally, we get to the advanced feeds, and this is where we can convert rapids to feeds, meaning we take G00s out of the program, and we replace them with G01 moves, and that's going to allow us to output a feed rate for when we're doing those G01 moves. So it's to help with an issue called dogleg rapiding. If you've heard of it before, you may need it, but most of the time you're pretty safe. And then right here you have percentages of your feed rate being used when you're doing a lead in or a lead out. When we're all done and we can't hit next, we'll just hit compute and let it calculate. And there is our tool path right there. So there's our front face path. So now I'm just going to right click on my feature lathe end face and just say blank unblank tool path. And then I'm going to go ahead and move on to the hole down the center. I'm going to drill the hole out of the center first. So I'm just going to right click on machine setup 1. I'm going to go to lathe hole. And then I can go and select my geometry. So when I say select geometry, all I need to really define is where the drill is going to drill to. So I'm going to pick this back point of this line right here and then hit OK. And I can actually adjust that as I do this. It's a lathe drill, so it can only go right down the center. So I'll go ahead and say next. Right here we have our feature. So we're going to have to define all of this. We have our clearance plane in front of the part, so 1 inch. Our rapid plane, I'm fine with 200 thousandths. Feed plane, 100 thousandths. I'm good with that. The diameter of the cut is 1 inch. The top of feature is at 0. The total depth that it's going to go is 7.5 inches. And then right now I have it set up as a through hole. So it's going to add 50 thousandths onto this 7.5. So it'll be 7.55 by the end of this. Next, I then have my machining strategy. I'll choose the lathe hole feature, which will give me a center drill and a drill. Next, again, I have my posting. So we could do separate moves or can cycles. Again, all depending on what your machine has and what your post has had worked out. And then right here, I have my center drill. It's a 1/2 inch, 90-degree spot drill. It's part of my tool crib. So I'll go next again. Right here for the parameters, we get to set up our depth of cut and our center diameter. So I'm just going to set this to 0.2 for the diameter. So it goes 100 thousandths deep. And then I'll just tell it to do that with a single step. Next, I have my rapids. Again, I'm going to use the default rapid on both the approach and the exit because most of the time when we're doing, OD kind of cuts, exterior cuts, we really don't have to worry about that. So we'll go next again. For the drill, I have my 1 inch drill. And so I'll say next again. Right here, we'll see that the overall depth is a 7.8504. And you'll see that the effective depth where we're getting the full cut is going to be that 7.55, that added 50 thousandths. Now I am going to go ahead and peck this one out, and I'll just say next again. And right here we have our rapids, so I'm going to use my default rapid approach and my default rapid on exit. So I'm going to hit compute, and there is my drill down the center of the job there. So then I could blank that one out as well. The next step is going to be turning from the front radius here all the way to the back of the part. So I'm going to right click on machine setup 1. And I'm going to go down to lathe turning. From here, I'll say select geometry. And I'm just going to drag a box over all of this geometry right here so it grabs it. Whatever you can select inside the box will get grabbed. And then I'm just going to add in the extra pieces right here just by clicking on them. And then right here, I could click on my chain and we could see it's going to start at the front face here. And it's going to go back to the back edge. So that's perfect. I'll then hit OK. Now, after hitting OK, I could just go next. And then right here, we have our rapid plane. So we're going to be 200 thousandths above the OD when we wrap it around. We're telling it that it's an OD cut and that we're using region 1. So basically, we're starting at the front face and moving backwards. If we go to region 2, it's going to do the back face towards the front. You also have a choice of doing ID cuts. And really what this feature type is doing is it's prepping the tool and the orientation of the tool so that it comes out properly. So I'm going to go OD region 1. And then right here, I have some undercuts. Now, grooves inside of your turning are seen as undercuts. Primary undercuts are turn grooves. Secondary undercuts are face grooves. And what these buttons do is they allow us to ignore or remove the geometry that represents the groove. So it takes this out of the geometry. So I don't have to worry about those, or I don't have to worry about adding a line across them to ignore those. So I'm going to say remove both of them. I don't have any secondary or face undercuts, but by turning it on, I'm just ensuring it doesn't run there. And then right here, I can tell it where to machine from. So I want to start from the stock, move to the center. So I'll say start from the stock. And then for the extensions, whether or not I add them, I don't think I need them. I'm also going to have a leads page here, so I could add leads to take care of that. But the extensions just allow me to extend either before or after the part when we run it. So I'll go ahead and say next. Right here's our machining strategy. So we have the choice of doing a rough and a finish, a pattern repeat, or a pattern repeat with a finish pass. So I'm going to go with the rough and a finish, but the pattern repeat is essentially just a series of cuts that match the geometry and just kind of step their way in for a finish pass. But I'm going to go with the rough finish here and then go next. Right here, again, we have our separate moves or can cycles. I'm going to go with separate moves. And right here, we have our roughing tool. So it's a CNMG. It's the same tool I used when I faced off the part earlier. So I'll just leave it there and say next. And once again, it's the same options we saw with the facing pass for the pattern. So we could go with a standard or an offset, and then we could choose either a standard or a zigzag pattern when we go to machine it. And you need the right tooling to be able to do this because you're going to be doing a back drag cut when you're doing your return. So I'm not going to do a zigzag. I'm going to go with standard. And then right here for my compensation, I'm going to turn on with collision detection using the tool holder. Next again. Right here, we have our depth of cut, and I'll leave that at 50 thousandths. I'm actually good with it taking that much. But this time we do have a finish pass, so I am going to leave some finish allowance on that part. The rough allowance is kind of an intermediate one. If you were to rough it out and then use some pattern repeats and then a finish pass, you can group them all together. But in this case, I want to rough it, I want to finish it, and then right down here we have our overlaps. So no overlap means that when it gets to its cut, it ends. It goes back to the beginning. If you set it up to previous cut, what it'll do is as it leads out, instead of just leading straight out, it actually connects to the previous cut and then leads out. And it just helps smooth the part out as it runs. You could also set up a custom distance that you want it to go instead of going to the previous cut. But I'm going to go to the previous cut. I'm not going to mess with any chip breaking on this one. And then right here we have our corner types of either round or sharp. So again, that's just the interpolation of the geometry when you make the cut. And then we have our trim to stock option there. Next, we then have our rapids. So the rapids, we have a default rapid on the approach and a default rapid on exit. I'm good with that. So I'll go next again. Leads, I'll start with a parallel lead in, so it's parallel to where we're cutting. And then just start with an angled lead out. And again, I like to change as little as possible. So if these are potential working options, then I'm going to leave them. Because if they work, I don't have to worry about changing them. If they don't work, I got to change them. So for now, I'll leave those there as the defaults. Right here's my advanced feed, so I can convert my rapids to feeds and then change my lead in and lead out feed rate percentages. Essentially, this is the same exact tool path as what we would have seen when we set up the facing pass. It's just the facing was oriented to cut the face. This one knows to cut the turn. So I'll go next right here. Here's our finish tool. It is a VNMG. Again, this is one that I set up inside the tool crib. So I'll go ahead and say next. For the patterns on this one, we could either do a continuous cut where we start from the front face and just go all the way back, or we could do an alternate cut where we face the vertical areas only, we turn the diameters only, or we do both. So we turn the diameters and we do a face for the verticals. So it's going to cut it down. But I'm going to go with just continuous and say on with collision detection using the tool holder. Next again, we have our parameters. No allowance because this is a finish pass. Next again, we're not going to change the rapids. Again, use the default leads if we can. And finally, we have our advanced feed rates. And when we can't hit next anymore, we hit compute. Now, after the toolpath finishes calculating, what I like to do is blank it out. So I can blank the whole thing out, and then I could go in and see the actual toolpath. Here's all the roughing, and here's my basic finish right there. So it's taking it all down. We'll see it's ignoring those grooves completely. And then I'm just going to go ahead and shrink this up. So the next thing we're going to do is these two grooves that we have right in here, and then a cutoff. So I'll right-click on Machine Setup 1. I'm going to go down to Lathe Groove, and then I'm going to select my geometry. Now the geometry for this is just going to be all of the lines for that. So I'm going to drag a box over pretty much everything right here, and then I'm going to deselect the things I don't want. So that and that. From here, I just look at my chains, make sure they're going from start to finish, from the front face back, and that's fine. And then I'll hit OK. Go next again. Right here we have our choices. So I have my rapid plane, my feature type, whether it's an OD or ID groove, whether I'm doing region 1 or region 2, so kind of depending on where I'm coming from, how it's orienting the tool. If I have angled grooves on here, I can have a tool that matches the angle, and I can actually set it to rotate that angle. And then right here we have our constraints. So I could say go from the stock, so it's going to go from where the stock was, but you got to think we've removed all that stock now. We could say go from geometry, which is from the top of the geometry, from the highest point in, or we could set up custom. So I'm going to say from geometry, no extensions, next. Right here we choose a groove, rough, and a finish. I'm going to use the same tool, but I want both of them. So I'll go next. Separate moves or can cycles. And then the groove. So this is my grooving tool, and I'm hoping this is long enough. I may need to adjust the stick out on this tool, which we can handle after this. We'll see what the results look like. But we have our left corner for our reference point, and that's saying it's referencing everything off there. We have our corner radius, tool width, tool height, side angle, total label there. The insert orientation, again, just the orientation of how that holder is sitting. We could set up a custom angle. We got our tool number, spindle direction, and feeds and speeds. So when we get into the groove patterns, we have 3 patterns, either a standard pattern, and with standard, you get a choice of sorting either standard, so you just go in order, 1, 2, 3, 4, 5. You could go from the center out, so you do half of it and then come back and cut the other half. We can alternate that. Or we can actually skip. So we cut one, we skip an area, we cut the next, we skip an area, we cut the next, and then we go back and clean up the areas we skipped. We could also do single passes. So that's just, I have a tool that fits a groove. I would just want to press it in and come back out, and we want to base it on either the beginning, the end, or the center of the insert. Or you can cut it with a zigzag. So actually zigzag your way down to the floor. But I'm going to go with standard. I want to use the tool holder for my collision checking. And this is really helpful for if this holder is too short, it's going to not let it cut into the areas that I'm trying to get into. So it should be able to protect us a little bit in case I didn't change the tool to the correct length. Right here for my parameters, I have my step over amount. So I'm using an 1/8 inch wide tool. I'll just leave it at 50 thou, but really go like a 1/16 of an inch would probably be fine. The allowance we're leaving for the finish pass, and whether or not we're taking this out in multiple depths. So you can actually step your way in. I'm going to leave it as just depth of cut, no multiple depths. I just wanted to cut to the bottom. We'll process by area. We'll do a one-way sort. And I'm not going to peck, but we could peck by setting up our first cut amount, our peck increment, and our peck clearance, as well as a retract if we want it. And then we do have that trim to stock option, so it knows where the geometry is. Right here for our rapids, again, it's an OD cut. I'm going to use the defaults. Same with the leads. I really only have one option, which is parallel, so I'll leave that there. And then our advanced feeds. We can convert our rapids to feeds. We also have our lead in and lead out feed rate percentages. Finally, we get to the groove finish. Should be the same tool. It's tool number 2. That's all good, so I'll go next. The patterns on this one is forced down cutting, so we have everything kind of meeting in the middle of the cut here, plunging in from both sides and cleaning up the groove from both sides. You could even add an overlap amount, or you could do just a basic finish. Start on one side and just feed through. So force down cutting, I'll leave the overlap at 0. On with collision detection, it's one of 2 options in this one. We don't have the on without collision detection like we have when we're turning. We'll just say use the tool holder. Parameters, zeroed out for the finish pass. No chip break, nothing else. Right there we have our rapids, our leads, and the advanced feeds. So when we're done with this one, when we hit compute, we should get a pretty good idea right away of whether or not it's going to work, because you'll see an angled section in the back of our groove, like right here. It doesn't go all the way down to the bottom. And that's because the holder itself can't physically fit. And the way we can look at that is by right-clicking on, say, the groove finish here and saying backplot. And we can see as it steps in, we get down to our depth of cut, and we're kind of maxed out there. So I need to go and fix the tool for this. And the easiest way to do it is to go into my lathe tools. So I'm going to right-click on turning tools, go down to the tool library, and then go down to the lathe section here. Now inside of Lathe, I can go to Groove. And what I'm going to do is I'm just going to create a new tool real fast. So I'll open up and add a tool. I'll double click on it. And I'm pretty much going to set it up as the same exact tool as what I had before. This is just going to be longer. So I'm just going to put this as 1/8 inch wide OD groove long. And I want to make it a separate tool because I don't want to go edit a tool that I'm already using. Now down here I can go to my holder and just say edit the tool holder. And right here we can click on the image and see what updates that. So right there I have this 5/8 length that's too short. So I'm going to make this just a 1 inch long area. So that's now 1 inch. And if I wanted to, I could even shorten it a little bit, really see how everything's fitting together. But 1 inch should be good enough. So I'll hit OK, and then I'll hit OK again. And that's going to add that tool into my library. Now I could either go into the tool crib and change it, or from the feature, I can edit my feature. I could go to my grooving tool, and I could go to the tool crib directly from here. From this one, I'll go and say add from the tool library. I'll pick my 1/8 inch wide groove that's longer and hit OK. And now I'll have two tools in here. So I'll hit OK. That's going to replace it with tool number 8. And then I'll go to the finish pass. Same thing, go to the groove, choose that same tool and hit OK. And that's all I'm changing. I'll then just hit compute. And we should see this tool path now go down to the bottom of those grooves. So we'll let this finish. And there it is. So now we'll go ahead and blank that out, shrink it up, and then the final pass is going and doing a cutoff. So the cutoff's pretty straightforward. It's kind of like drilling. We just have to give it a point to cut to. So I'm going to right click and say Lathe Cutoff. I'll select my geometry. Once again, as the back corner of the part works out just fine, so I'll pick it right there and hit OK. And that's really just so it reads how deep it needs to cut. I'm going to tell it to start from the stock. Right here's our strategy. I just have my cutoff. Right here's my posting, separate moves or can cycles. Right here's my cutoff tool, which I already added in. It's long enough to make the cut, so I have it right there. Right here's my parameters. So it knows to go back 7.5 inches. It thinks it should only cut off to this 0.4993. But really with this, it's going to cut off because there's a hole in the middle. It's going to cut off around 1/2 inch up anyway. But if I say go to 0, it'll cut off all the way to 0. We also have the ability to go in and add a corner break. So I could have it add a chamfer or a fillet to the back edge without me having to draw that geometry if that's what I wanted. And then we can also peck our way in. So there's pecking. I'm going to leave it with all the defaults. 100 thou for the first amount. Increment after that's 100 thou. And then we have our clearance. And then finally the rapids. I'm going to use the default rapid on approach and the default rapid on the exit. When I'm all done, I can hit compute. And there is our cutoff to the center. So what I would recommend after this, I'm not going to go through it, but I'm going to go ahead and say start the simulation, watch it run. It should all work pretty decently. Most of our exits are good. And now that we fixed the groove, we really shouldn't have any problems with this part anyway. And that concludes the video on the lathe tutorial for BobCAM for RHINO.